Okay? Doesn't matter whether this is positive or negative. It doesn't matter that x is greater than a negative 3. Answer might be positive, might be negative. That's not what it's about. A negative coefficient is what changes the direction of the answer, so you have to flip it back to keep it true. This is our inequality statement. Okay. A basic number line. Our boundary point is negative 3. Is it included or not? No. So we'll use a parenthesis right on negative 3. It's going to be facing up because we are drawing up the number line. Okay. And for our interval notation, we start with negative 3, right? Smallest value, negative 3. And with a parenthesis or a bracket, comma, infinity, parenthesis. Just like with an equation, no decimals or fractions, but we'd have parentheses. Distribute those and combine any like terms, if there are any, before you start hopping over the inequality symbol. Should I move the 2x to the right or the 3x to the left? Yes. Even though it's going to make it negative, doesn't matter. Move it to the left. If you don't believe me, you're not sure why I'm saying this, then make a point of trying both ways in homework. And hopefully you'll see like where that confusion can come in if you don't always move it to the left. And the constants will always go to the right. Yes, absolutely. Because what is our coefficient? Yeah. Our last step is to divide away the coefficient, which is negative 1. So that becomes positive x. And immediately flip that symbol. Okay. Negative coefficient. Then flip the symbol. And this gives a solution of
4 to infinity.
Right.
And the 4
Well, not 4 to infinity, no.
4 to
Right. Because our boundary point is 4. And are we going to be going down the number line or up the number line? Down. X is everything less than 4. So our boundary point is 4, and it is included. And just like the inequality symbol, we're doing that arrow, we're pointing down to the left, which is in the direction of negative infinity. Okay. This arrow right here, really recognizing how that arrow on the number line mimics the inequality symbol. Even if you're not as directionally challenged as I am, that's something that's going to really help with the absolute value ones next week, which get a little more confusing. That's brand new material, and seeing that relationship is going to help you figure out which order things go in. Smallest value, comma, biggest value, which is included. Yes?
On the first one, shouldn't the negative 3 be a bracket?
No, because there's not an or equal to line here. Okay. So x is greater than negative 3. We start at negative 3, but it's not included. No. Infinities always get the soft parenthesis. The number may get a soft parenthesis or a bracket depending on whether there's an or equal to. How many terms do I have right now? Exactly. Don't unlock them or you'll have 4 and you'll have more fractions. Okay? Deal with this as one quantity. What's our LCD?
15.
It's all cleaned up. We're ready to distribute now. Even though it's going to make it negative, doesn't matter. I'm moving that 12x over to the left. At the same time, I can push the constant over to the right. Final step, dividing away. Right. Which means,
It's greater than or equal to.
yes. Okay. We had a negative coefficient. It doesn't matter whether the 12 was positive or negative. It doesn't matter that the solution happens to be negative. The negative coefficient means we flip the symbol. Pointing up the number line. So we start at negative 6 as our boundary. It is included because of the or equal to. And we're going up the number line. Smallest value is negative 6. And the biggest value is what? Infinity. Positive infinity. All right. Okay.
So basically, for the flip of the sign, it's not if the coefficient is negative. It's whenever it's the opposite of the sign. That's the number on top.
No, if the coefficient, it literally is if the coefficient is negative. Okay? So here our last step is to divide away the coefficient, and our coefficient is negative. Therefore, we have to divide by that negative coefficient. Therefore, we flip the symbol. Here, our coefficient was positive. So the symbol does not get flipped. Here, the coefficient is negative, a negative 1. Therefore, the symbol is flipped. It's purely and only based on if your coefficient is negative. It doesn't matter any other negative signs. It doesn't matter what happened before up here. The last step, if that's a negative in front of the x, the symbol gets flipped. Good. Other questions? Okay. So this is all single variable equations and then single variable inequalities. Okay. You can see the solving with the general strategy is just the same. There's just this one exception with that negative coefficient has to flip the symbol because otherwise it gives you a false return. Okay. And of course, the answer means something different. Your answer is not the solution, it's the boundary of the solution. So it's where your solution begins, and you indicate that by writing it, graphing it, and writing it in interval notation to show that your solution is everything in between these values, not just a list of single values. Now we're going to look at two variable, once you graph, two variable equations and inequalities. Okay. So to start with, very quickly, we're going to do some Oh, graphing. So everybody should have some graph paper. So there's 4 graphs on the front and on the back. We're going to do equation practice on one side and inequality on the other. So we'll use all 4 graphs. So, I'm going to go through this a little quickly. This is all from Chapter 8. It's all from graphing. Review of 308 if you were in the 308 class. If not, then this might have been fresh, but it's all from that Chapter 8, from the unit on graphing. So, if any of this is a little like, oh, then it's not going away. It's going to be a big topic not on the final and as well, especially in college algebra. Graphing is key. So, in order to graph inequalities, you have to have the basic skill of graphing an equation first. Okay? Just like, talking about here, you'll see how it's connected. It might not be all the same expressions. With an equal sign, you get that's the solution. Well, if it's the same expressions, but with an inequality symbol, you still get that same number 3, but instead of being the solution, it's the boundary of the solution. It's the same thing with 2-variable equations. If you just graph a 2-variable equation, you get a line. That's your solution, the line on the graph. If it's a 2-variable inequality, then that line is not the answer. That line is the boundary of the answer. And the answer is everything on one side or the other side of the line. But the basic skill of finding that boundary point, finding the single boundary point for a 1-variable equation or finding the boundary line for a 2-variable inequality is that finding that boundary line is the same skill. So this is from chapter 8.1 to 8.6. Okay? All the stuff we did with functions and graphing, specifically linear graphing. So I'm going to put some equations up here, and whether they are in standard form or slope-intercept form, bless you, you need to know how to quickly put them on the graph. So, of course, if it has an x and a y, it's going to be a diagonal line. If it has just an x or just a y, then, of course, it'll be a horizontal or vertical line. What form is this one in? Slope-intercept form. So you don't even have to do any math to graph it. It tells you everything you need to know. It's going to tell you your y-intercept, which you plot that point, and then from that point you count off your slope. What is the y-intercept of this slope-intercept form equation?
0.
0, exactly. If there's no constant, you got an x and a y, so you know it's diagonal. If there's no constant, then your constant is 0. And that is your b, and your y-intercept is just 0, comma, b. Okay. And in this case, our b is 0, so our y-intercept is the the what? The origin, great. So if you have an x and a y, whether it's in standard form or slope-intercept form, if you have an x and a y, you got a diagonal line, but if you don't have a constant, then your line goes through the origin. If you did have a constant, it's like plus 3, then you plot the point 0, comma 3. It would be here, for example. And then from that point, in this case, that y-intercept is the origin, count off your slope. What's your slope?
2/5.
Now, with a slope of 2/5, are you expecting an upward or a downward line?
It's upward.
Upward. Positive slope means upward. And this slope is less than 1. The absolute value of it is less than 1. So is it going to be a shallow line or a steep line?
Which is kind of like
Shallow, yeah. 1 is the medium. Anything smaller, the smaller it gets below that, the shallower it gets. The greater than 1 it gets, the bigger it gets. So you're expecting a positive upward line, an upward line that's kind of shallow. So up 2 over 5. That's positive 2, positive 5. You can also go negative 2, negative 5. It's the same thing. And there's your shallow upward line. How many points are on this line?
infinite.
Infinite. I just graphed 3 of them. but there's infinite points there, infinite ordered pairs. And so the solution to this equation is the graph of this line. And any ordered pair that is on the line, if you plugged in the x and y value of any ordered pair on this line, you plugged it in here, you would get a true statement. There's infinite ordered pairs you could plug in here and get true statements. Now there's also infinite ones that are not on the line that if you plugged them in, you'd get a false statement. Remember, the solution of this is an ordered pair that falls on the line. So you plug in an x and a y. If it's true, that's an xy that's on the graph. If you plug in an xy and it's false, then it's an ordered pair that is not on the graph. Just like this, 3 is the only thing that will work. Here, any ordered pair that's on here are the only things that will work. Anything other than 3 for the one variable or other ordered pairs will give you false statements, and they're not solutions. All right? So here, standard form. My first instinct will be, hey, standard form is real simple to get 2 points. Instead of a point and a slope, I'm going to get 2 points. My little t-chart so I can cover up. It's just a quick way. This is the definition. X equals 0 is the definition of the y-intercept. Y equals 0 is the definition of an x-intercept. So if x is 0, covering up just means it can go in this form. That just makes it go away, and I write down what I see. And that gives me that point. When y equals 0, I'm going to have my x-intercept. If y is 0, it just goes away, so I can just cover it up, and I write down what's left. Solve for x, in this case, divide each side by 2. And that gives me the point 7/2, 0. Now, if one of your points includes a fraction, then it's not as precise to graph that. And also, just to check your work, it's a good idea to go ahead and find slope. So for standard form, how do you find the slope?
I just moved the x over to side minus 2.
Yeah, this one was easy to solve for y if you just wanted to change the slope-intercept form. True. But if you weren't going to do it, that's one method. The other method is, what's the little formula that allows you to find the slope? Sorry? That's if you're given 2 points. Yeah, the that's yeah. Sorry? Remember, standard form is capital AX plus capital BY equals capital C. Remember the little formula for slope, if you have standard form. No, that's if you're given 2 points. You subtract the y's on top and the x's on the bottom if you have 2 points. In standard form, remember that one? To find the slope, if it's in standard form, and you remember this is part of standard only for standard form formula because it's got the capital A and capital B. This standard form is capital AX plus capital BY equals capital C, meaning that we're not using fractions, just integers. Now, if you, as you said, you solve for y, that means that x gets moved over here and becomes negative 2x. That's why this formula flips the sign of the slope. Okay? And then you divide away any coefficient of y, and that's where the b comes from on the bottom. Okay? So if you solve this for y, you end up with what is essentially negative a over b. So if you don't want to solve it for y, you can just find that if all you want is the slope, you just put your a over your b and you flip the sign. If you've got a plus sign here, your slope is going to be negative. If you've got a minus sign here, your slope will be, because the little formula flips the sign. So negative, our a is 2, and our b is 1. So I can plot one or both these points. I'll just plot the really clean ones, 0, 7. And then I'll count either down 2, 1 to the right, or up 2, 1 to the left. So down 2, 1 to the right, or up 2, 1 to the left. Either way, I have that steep downward line. And any ordered pair, infinite ordered pairs on that line are solutions to the equation, and any ordered pairs that aren't on it would make the equation false. Okay? So finding the 2 intercepts and the slope, important skill. Okay? All right, what kind of line is this here? Is it diagonal like these?
No, it's vertical.
Vertical, right. And it's already in its standard form, so you don't even have to worry about slope or anything because the slope of a vertical line is
0.
mm-mm,
Undefined.
undefined, right. So finding slope isn't going to help you graph it. If you know that's a vertical line, that means that it is a vertical line going through the point -4 on the x-axis. You don't even need another point. That is the x-intercept. There's no y-intercept. Slope is undefined. You just need that one point, and you draw. So that is a vertical line. Done. Okay. This one right here is
It's a horizontal.
horizontal. This is not a typo. There's just a y, no x, making it horizontal. Is it ready to graph? Do you know what your y-intercept is yet?
You can just switch the 5 over.
Right. So you get 3y equals, and so there. So you have to solve it for x or y first, and then you can graph it. And that will, of course, give you a horizontal line. So that's y-axis has a y-intercept of 3. What's the slope?
0.
Mm-hmm. The y-intercept is 0, 3. There's no x-intercept. Okay. So being able to graph that slope-intercept form, standard form, or horizontal or vertical lines. Okay. If that was shaky, we need to review. It's going to show up on the test, and graphing is, college algebra is very focused on graphing, and not just the linear family, but other families. Okay. So, linear inequalities now. So as I kept pointing out, these lines are the solution to this equation. And only points on this line will satisfy that equation. But with an inequality, we're still going to be working with an understanding of that line, but that line will not be the solution. That line will be the boundary of the solution. So we're going to come back to the graph paper in a second. Let's talk about finding. This is in 8.7, so we're going back to the end of that chapter 8, and this is graphing 2 variable linear inequalities. So instead of graphing equations, it's graphing the inequalities. Okay. So, as an example, and then to walk through what the steps are, let's do y is less than 4x plus 3. Okay. All right. So, step 1 is you graph the related equation. And when you graph this related equation, what you are getting is your boundary line. If this were an equation itself, just an equation, the boundary line wouldn't be a boundary line, it would be the solution. You're done. Walk away. But this is just going to give you the boundary, the edge of the solution. So, in this case, you are going to be graphing y equals 4x plus 3. You just put in an equal sign instead of the inequality sign. Okay. I'm just going to do a really quick little graph here. I see that my point of my y-intercept is 0, 3. And my slope is 4, or 4 over 1. So I start at 0, 3, and I go up 1, 2, 3, 4, and over 1. Okay. So there's my line. But before I draw in my line, what I need to ask myself is, right, if it is less than or greater than, then is my line going to be included in the solution? Is your boundary included when it's less than or greater than?
No.
No, it's not included. So this means, not included. So therefore, use a dashed line. But if you have less than or equal to or greater than or equal to, then your boundary line is included. Therefore, you will use a solid line. This is like using a parenthesis versus a bracket, or a closed circle versus an open circle. The dashed line says your boundary line is not included, and a solid line says your boundary line is included. Yes? Okay. So this, I'm going to draw a solid or a dashed line? Dashed. So I draw the same line as if I was drawing just what? Graphing y equals 4x plus 3. But because this is actually just to set the boundary of my inequality, and it's a less than or equal to this, not or equal to, that means my boundary line is not included. The dashed line tells me that. Now, your solution is actually going to be everything either on this side of the line or on this side of the line. So now you have to shade the correct side. Now, a lot of times this is very intuitive. Okay? You'll be able to see, oh, if it's less than, if it's less than, then, well, I don't know, less than could be, is it to the left or is it to the right?
Is it to the right?
Okay? But you asked me with a question. Is anyone certain which way it is?
I'm pretty sure it's
Yeah.
no.
Pretty sure that's it.
Okay, let me think. Y, so y needs to be less than, so it's going to be to the right. Yeah.
To the right? Okay. So some people can very easily intuit this. Okay? And some can think about it for a second and intuit it. And sometimes it's really obvious, and sometimes it's like, wait. The best thing I can recommend is to next do a test point. Okay? It's kind of a quick way to check which side to shade. Because, like I said, sometimes it's intuitive, but sometimes it's just not. Okay? So if you do a test point, you'll know for sure. Okay? So by a test point, I mean you test one point that is either on one side or the other. Because here's the thing about a test point. If the test point is good, then everything on that side is good. If the test point is bad, then everything on that side is bad. Okay? So you don't have to test, there's infinite points on this side and infinite points on that side. You don't have to test all those infinite points. One point will tell you whether it's on this side or on this side. Okay? So, the test point, it doesn't matter. There's infinite points you could choose from. Just don't choose one that's on the line. Okay? You have to choose one that's off the line. So, you have infinite choices. In general, unless your line goes through the origin, then the best test point to use is just 0, 0. Okay? You don't have to, but I just recommend it. Now, if it goes through the origin, then you can't use 0, 0 because you cannot use a test point that's on the line because you want to see something off the line. So if it goes through the origin, I suggest using 1, 1. Now, there are some lines that go through the origin and 1, 1. If it's got a slope of positive 1 and no b, it goes through the origin and goes through 1, 1. So other possibilities are like 0, 1 or 1, 0. Okay. And really, you could choose anything you want, but why make your life more difficult? If they match and they're positive, that's the easiest thing, or other just keep it low and positive. Okay. So all the test point is doing is we go back to our original inequality, y less than 4x plus 3. And my test point, because this doesn't go through the origin, my test point, I'll even mark it here, is the origin, 0, 0. Okay. And so I'm going to plug in that test point. So I'm going to plug in 0 is less than 4x, which is 4 times 0, plus 3. And I'm going to put a little question mark, because the point is I'm testing it. It might be true, it might be false. Okay. So I finished simplifying.